Okay guys, welcome. This is my first video tutorial. Let's see how it works. So what we're going to see today is how to export your models, your fusion models, so we're able to cut them in the CNC router. Okay. First of all, we open Fusion 360. These are my sample pieces. This should be similar to yours. In my case, this is 1.2 millimeter sheet metal. So here you can see 1.2 millimeters. And I just have these 4 samples as well, we're going to be working with them. All right. So we basically have the 4 bodies we can see here, and this is just the model environment. I already modeled them, and in my case, what I did also was to have a diameter of 4.763. Okay, so I went to the lab, and basically they have only 2 choices for the drill bits here, and those 2 choices are this 1/4 of an inch, which is 6.35 millimeters, or the 3/16 of an inch, which is 4.7625 millimeters. Okay, so the only 2 choices you have for your project are these 2 drill bits, either 6.35 or 4.76 millimeters. Okay, basically this is what we have, and you should design your pieces based on these 2 drill bits that we have. Okay, so I went for the smaller one, the 3/16. So basically, since we're using everything in millimeters, I just change that to millimeters. In my case, the resolution goes to 3 decimal places, so instead of 7625, it's 763. Okay, great. So these are my pieces. That's the drill bit diameter, and once we have them, basically you should put all your pieces here. Let's say I'm just cutting 4 of them. If you have 14 or 50 or 100 or whatever, you just need to put all of them here in this environment. Okay, so once we have that, let me just put it closer. Yeah, so once we have that, we just click here, and from model we go to CAM. Okay, which will generate the toolpath for basically cutting this on the CNC router. So as you can see, all this menu on top has changed because now we're in the CAM environment, and what we need to do here is the following. Normally we start in this direction, okay, from left to right, and this is sort of the order in which we should be designing our manufacturing process. Okay, here, well, we have the components. Okay, automatically they are there, and we need to start with the setup. Okay, so we go here to setup and new setup. Okay, now I'll explain everything, but the first thing you will notice is well, when this little hand appears, you have to click escape on your keyboard so it goes away, and we're able to move everything else. All right, so once we have the setup, you have 3 different options. We start with the first one, and in our case, for the CNC router as well as the CNC milling machine, the operation is going to be milling. Okay, where we can either have milling, turning, or cutting. Okay, we don't have a water jet or plasma configuration, so we're going to be doing milling in the CNC router. Okay, so we start with milling, and then we go to the coordinate system. Okay, in our case, basically the origin, we need to define the origin for where we will start cutting. Okay, what I normally do is to define the origin here in the left hand side part of the design, right? So in the bottom left, like this point here, and what I need to do is select one of these. Okay, so I'm going to select the selected point. Okay, a selected point which I will define, and I just go and click sorry, here, stock box point, and I'll click this one, right? So this will be my my starting point. So as you can notice, there's a stock, which stock means like the material that I'm going to be removing. In this case, this will be your sheet metal, right? And I will define it afterwards here where it says stock. But for now, let's just select a point here. And as you can see, these coordinates are not as expected, right? If I'm looking at the design like this, let's say this will be the base of my CNC router, and I want to have the Z axis going upwards, right? So instead of having the Y axis here, I want to have the Z axis here. What do I do? Well, basically, I need to change, nope, here, the model orientation, right? So in the model orientation, I need to select the Z axis, all right? So what I do is basically click one of the lines from my design that goes upwards. So I will select this as my Z axis, right? Just like here. And then the Y and X axis are as expected, okay? But now I just changed the origin, and I need to go back here and select the point being here, right? So now I have the right orientation and the right starting point for my cutting operation, okay? You should have it like this: Z going upwards, and then Y going in this direction, and X axis going in this other direction. You can see they are not the same axis as my design, but basically I want to have it like this. So you should have your design as well, something like this. All right. So with this, we have defined in the setup the operation type as milling. The work coordinate system, we selected the Z axis and the origin point. And the model, we have these 4 bodies. Okay, so you don't have to change anything there. Then we go to stock. Here in the stock, basically we want to have a relative size box, okay? And in this case, this, instead of being a box, it's going to be your laminate, okay? Your sheet metal. And here we can set the offset. So let's say we will have a side offset of about, I don't know, let's say 4 millimeters, okay? So as you can see, this shadowy, like gray area just became wider. And the top offset, we don't want to have any offset. So if I have 1 millimeter and I look at it from this area, you can see there's a little offset here, right? I don't want to have any because I will be basically machining the whole sheet metal. So if I put 0, it goes down to the same width as my, the same thickness, sorry, as my pieces. Okay, so we want to have it like that. You can define this offset, but I would suggest 4 millimeters, and then stock top and bottom offset, just leave it like 0. Okay. So these are the dimensions that basically I just created. Okay, and you can, well, this you will know that at least you need a 72 times 46 millimeter sheet metal to cut these 4 parts. Okay, and this is in my case the thickness of my sheet metal. And now we go to post process, and basically you will put here your program name, whatever. I will just put 3, okay, and the rest just leave it like that. And once we agree with this, we just click OK, and we have our setup here. If we need to change it some, well, because something went wrong, we just right click and go to edit, okay, and we go back to the same, to the original area where we can change everything. And we click OK, and then we'll continue with the second operation. So once we have this, we want to do 2 things. So one of the operations is to basically cut the perimeter of the pieces, right? And the other one is to drill the holes. All right. So we first want to drill the holes, and then we want to cut the pieces, right? So let's go to drilling. Now we go to the operation parts, and we will go to drilling, right? So we select drilling, and we need to select the tool, right? So this is the first menu that appears. We go to tool, and then we click select, right? I have some tools here, but let's just start from the beginning, right? I will just delete them so you can see everything from the start, okay? You'll be prompted with this screen, right? Let's just say okay. Now I'll click it again. We start with, let's just put cancel so you can see everything again. We go to drilling, right? And then the first option is tool, select, right? We don't have any tools here, so we have to add the tools. We go up here and click this one, new mill tool, right? And we're prompted with a library as well. So we go to general, there's nothing here in general, and then we have to select the cutter, okay? There are different cutters here, and we want to select drill because, well, it's a drill bit what we need right now. So we just click here on drill, and remember we have the millimeters, right? And the number of flutes, the flutes, it's basically how many cutting edges our drill bit has. And normally for these ones we have 4, okay? So we'll just put 4 number of flutes. And the material, it's normally high speed steel, HSS, okay? This is the cheapest one, so this is the ones we have. We don't have coolant going through the tool, so it says no, and the clockwise spindle rotation, which is the normal rotation, okay? And now we need to define the diameter for our drill. So remember, these were our 2 options, either 6.35 or 4.76 millimeters. I'm using this one, so this is the one, the value that we will put here, okay? 4.7 4.763, all right? 763 rounded to the third decimal, okay? 4.763, and the rest we'll just leave it to automatically update, okay? So that's for the cutter. It's a drill bit, 4 number of flutes, high speed steel, no true coolant, millimeters, and the diameter, that's the only thing we need to change. Then we go to shaft, we leave it as it is, holder, again, feed and speed. Normally we work with 3000 RPMs with our spindle speed, and then the vertical feed rates will just leave it at 100 because we don't want to be going very fast, okay? And post processor we leave it as number 1. All right, so that's it. General, we do nothing. Cutter, we already changed. Shaft and holder, we do nothing. Feed and speed, spindle speed 3000, and the feed rates at 100 millimeters per minute. Post processor, NC number 1, and everything, just leave it as it is. And then we click OK. So this is going to be the drill bit that will drill the holes, and now we can also put the cutter that will actually cut our parts from the sheet metal, right? So in this case, the one we have is 1/4, right, and 1/8. So let's use this one, which is smaller, and this will give better results for our case. So we have to select this one in the database, right? Now we go here again to the database, and in the cutter we'll select a flat end mill, okay, because these are the ones we use as well for the CNC milling and the CNC router, okay? So we select flat end mill. Again, the ones we have are 4 flutes, material the same, high speed steel, and millimeters, and basically the diameter for 1/8 is 3.175. 3.175 millimeters, okay? Again, we just leave it as it is, and spindle speed 3000, and the vertical feed rate 33 millimeters per minute, that's okay. And here, cutting feed rate, again, let's leave it at 100, okay? Post processor, if it says number 2, let's just change it again to number 1. This is normally in the case that we have an automatic tool change in the machine, but we're going to do it manually. So this one and the drill bit will be number 1.